Imagine a bag containing 4 balls labeled 1, 2, 3, and 4. 2 balls are drawn from the bag randomly with replacement, and the sum is recorded. Find the probability that sum is 3 happens before sum is 5. So let's start by defining the events that we have. So let's say we have event C1, and this is the event that we have sum equals 3. And then we'll have the event C2 that sum equals 5. And let's find the probabilities of these two events. So in this case, we can, because the numbers are small, we can write down all the outcomes that we have. So let's say here we have the first ball number, the first ball number, and the second ball. So what can these be? Well, we have 1 and 1, we have 1 and 2, 1 and 3, 1 and 4. And then we have 2 and 1, 3 and 1, and 4 and 1. And then we can fill in the rest of this. Okay, so here's the total set of outcomes that we have. And if we look at this, there's 16, which isn't unexpected because we have 4 options for each of them, and there's 2 balls, so that means 4 squared, which is 16. But we can also see that here. Now let's look at this and figure out which of these outcomes satisfies sum equals 3. Well, if you look at them, that only happens with this one and this one. These are the only outcomes where sum equals 3. And then what is the outcomes where sum equals 5? So that's these ones. These are the ones where sum equals 5. So from this, we can now say that the probability of event C1, which is the sum equals 3, that is 2 out of 16, or 1/8. And the probability of C2 is 4 out of 16, or 1/4. Now, this is not representing everything because C1 and C2 are not exhaustive over the whole set of outcomes. There's still situations where neither of these are met, and that's what's remaining here. So there's a total of 10 out of the 16 that don't fall into any of these. So the probability that it's not C1 and it's not C2 this is 10 out of the 16, or 5/8. So now the question was really asking us, what's the probability that basically event C1 happens before C2? So something happening before something else introduces an idea of time, or in this case, trials. You can think of it as repeating an experiment, and you want to know what's the probability that something happens before something else. So let's break this down. Let's make a little table. We say the trials that we need. The trials needed, the situation or the case. You'll see what this means in a second, and then the probability. So we're trying to look at this from the perspective of sum equals 3. That's what we want to happen. So if we only need one trial, meaning one time we reach into the bag and we get the 2 balls, If that only happens one time and we want the sum to equal 3, then on that time the sum has to equal 3. So the sum has to equal 3, and of course we just found out that the probability of that happening is 1/8. Now if 2 trials are needed, so 2 times we're looking into the bag, well again, we want the sum equals 3 happening before sum equals 5. So on the first trial, the sum cannot be 3 and the sum cannot be 5. On the second time in that trial, we want then the sum to equal 3. So this means on the first trial, it's neither sum equals 3 nor sum equals 5. So this is that 5/8 that we had. And then on the second one, we have sum equals 3, which is the 1/8. Now we're trying to see if there's a pattern here. So let's go to the next trial. So if we need 3 trials, so again, the first 2 trials, the sum can't be 3 or at 5. On the second trial, the sum can't be 3 or 5. But on the third trial, the sum has to equal 3 for this to work. The probability of this happening is 5/8 on the first 2 trials, so 5/8 squared, and then 1/8 on the last trial. Now you might be recognizing a pattern here. Every time we increase the trial, we are multiplying the probability before by an additional 5/8. Now this might look familiar to you. This is often the case in probability, especially when you have a series that you're putting together here. You might need the geometric series formula. So what is that? So the geometric series formula, the sum of a geometric series, looks like this. So we have the sum from n equals 0 to infinity of some constant a, some ratio r, raised to the nth power, and assuming that this holds, meaning that r is, the absolute value of r is less than or equal to 1, we have that a is 1 minus r. So going back to this question here, we have a sequence. We have the 1/8, then we have 1/8 times 5/8, and then 1/8 times 5/8 squared, and so on and so on. Because we're trying to find the probability of some event happening before something else, we have to look at all cases. So we need to add together all the probabilities for all possible trials. So that would go from the starting trials all the way to the last trial. So we want to sum this together. So what do we get? We have the sum n equals 0 to infinity of 1/8, 5/8 to the n. And does this make sense? Well, n here is 1 less than the trial number. So when n is 0 means the trial is 1, the probability is 1/8. And here, if n is 0, this is 0, this turns to 1, we get 1/8. When n is 1, meaning we're at trial 2, we need 1/8 and 5/8. So this is 1, 1, 1/8, 5/8. So this is working. This is following the pattern. And because 5/8, the ratio here, the common ratio, 5/8 is less than 1, we can use this relationship. We know that by the geometric series, the sum of an infinite geometric series, we know that this is equal to 1/8 divided by 1 minus 5/8. And when you calculate this, we get 1/3. So this means that the probability that sum equals 3 happens before happens before sum is 5, this probability is 1/3.